Good morning. Today we're going to start talking about lesson 6.1 or unit 6. Before we do that, I want you to go ahead and actually graph these two lines as a review from unit 4 and unit 5. So if you try these, you will notice that this first equation is in slope-intercept form. So when it is in slope-intercept form, we are going to find our m and our b. So we started at 2, and then we went down 3 over 2 to graph that line there. Lost my cursor here. And for the second line, you have Voxer-Hoy, that is a vertical line. So we are going to go over to where x is equal to 2 and draw a vertical line straight up and down. So that leads us into what we're going to talk about in Unit 6. We are actually going to talk about systems of equations, which is a set of two or more equations containing two or more variables, and we're going to focus on just two equations with x and y. The solution is an ordered pair that works in each equation, typically represented by the point where they intersect on the graph. But we will talk about how to solve them without graphing. And then there are ways to classify this. I'm not so worried about those for you, but I'm going to explain it a little bit as we go. This first problem here, this first example, think of these as two people who kind of live their lives, never meet, never interact, they just kind of do their own thing. Since they never meet, they never cross, there is no solution. Okay, so you can use an empty set or no solution. We consider these inconsistent. Okay, typically we have two people who are living their lives and they might meet at some certain point in time, but then carry on with their own lives after that. This is when we have one solution, and if there's one solution, you need to tell me what that solution is. So if I find that ordered pair, I go over 2, up 5. My solution is 2, 5. You do not have to write out one solution and no solution every time. Just give me the empty set or the actual point and you'll be good. These are consistent and independent because they kind of do their own thing. And the reason we say they're independent is if you look at the third case, this is actually two lines graphed on top of each other. And we all have that friend who, when they started dating somebody, they became inseparable and one never went anywhere with the other one. So that is how I describe this line. This is infinite solutions because they are always together at every single point. And if you look at the description up here, infinitely many solutions means dependent. Okay, they depend on each other, they go everywhere together. You know that situation. Okay, so you're either going to write the empty set or no solutions. You're going to give me an ordered pair if there's one point. Don't have to tell me this, I'm not worried about that. Or you can tell me infinite solutions. Okay, let's go ahead and do some of these and make this a little bit easier to deal with. I'm going to graph this first equation in red, and we're going to start by finding our m and our b. Remember, if there's not anything there, we can put a 1 over 1, and our b is -3. So I'm going to start at -3, and I'm going to go down 1, right 1, because my slope is negative. And I'm going to go ahead and draw a nice, straight, very accurate line that goes all the way across the graph. And those of you who are in our code-taught classes and have Mrs. Straight, she has been telling you this for a long time now. It's really important that you draw those lines nice and straight and all the way across your paper. So we're going to go ahead and do that. And then I'm going to go ahead and draw my arrows at the end. And then we're going to graph the second one in a different color. You don't have to do this on your paper. I'm just doing it so you can tell the difference between them. But in this second problem, we have our m and our b. Our b tells us to start at a +2. Okay, remember, always on our y-axis, and then our slope is positive, so we're going to go up 3, 1, 2, 3, right 2. Or I could go down 3 and backwards 2 if I want to get a more accurate line. And then make sure you use a ruler, your ID, driver's license, whatever you've got to make a nice straight line at home and draw that line. So what we just did is we graphed two lines on the same graph, which isn't too bad. It's very similar to what we've been doing in the past. But you have one more step now. Just graphing these isn't enough. I need to know if they cross, where they cross. So tell me the location of this point where they intersect. Remember, we're going to go sideways first for a point and then up and down. So we're going left 2, down 1. So our solution is -2, -1. Okay. Next example, both of these are in standard form. So we're going to go ahead and graph that. When we did standard form, remember the cover-up method. So if I cover up my y, I'm left with 2x equals negative 2. So if I divide, I get x is negative 1. And if I cover up my x, I'm left with negative y equals negative 2. So if I divide by negative 1, I get y equals 2. I'm going to draw a nice straight line there. I'm just going to leave it black this time. Okay, so there's my nice straight line. And then we are going to go ahead and do the same thing with the second line. So same thing, cover up, find your x-intercept and your y-intercept. I'm going to do that one in red. So if I cover my y, I'm left with x equals negative 6. Doesn't fit in my graph, I'm going to approximate it, it's about right there. If I cover up my x, I'm left with 2y equals negative 6. If I divide by 2 on both sides, you get y equals negative 3. So I'm going to go ahead and graph that. Now, some of you have been trying to solve these for y and put them in slope-intercept form. Instead, I highly recommend or caution you when you're doing that, because I'm seeing a lot of mistakes that are really going to throw you off here if you do that. So work on using cover-up method, graph those, find the point where they cross, which is left 2 or negative 2 and down 2. Okay. We're going to go ahead and do 2 more. The next one has 1 in slope-intercept form and 1 in point-slope form, or sorry, 1 in standard form. So if I cover my y for the first one, because it's in standard form, I get x equals 4. So I'm going to go ahead and plot that. If I cover my x, I get 2y equals 4. So when I divide by 2, I get y equals 2 on both sides. And I can go ahead and draw that line. What we were seeing on yours as assessments before our time off here is that a lot of you are still getting mixed up between standard form and slope-intercept form. You need to really pay attention to whether that y is alone or not. If the y is alone, then you're going to use rise over run. If the x and y are on the same side, then you need to do the cover-up method. Okay, so the second one, the y is alone, so I'm going to find my m and my b. So my m is negative 2 over 1. It's not a fraction. I'm going to start at negative 1 and then go down 2, right 1, down 2, right 1. And then draw a nice straight line. Okay, and again, we're looking for the point where these cross. So I have negative 2, 3 as the point where they cross. So negative 2, 3 is my solution. Okay, last problem. It's a word problem. Do not skip it, because to get a 3, you have to be able to do word problems. So today the temperature in New York is negative 1, so I'm going to start at negative 1. And each day it is expected to rise 3 degrees. So if we go up 3 each day, it looks like this. Okay. Then draw your line. And go ahead and do the second one. It's 6 degrees in Alaska, so we're going to start up here. And the temperature will fall 1 degree every 2 days. I graph. No, I didn't. Okay. So fall 1 degree every 2 days. Fall 1 degree every 2 days. Sorry, my graph on my paper is different than this. So it's falling 1 degree every 2 days. So I went down 1, right 2. I'm going to go ahead and draw my line in there. And you'll notice that they intersect right at the top of the graph there, which is at 2, 5. Now, when we were doing this, this is what we use. Okay, so our temperature for the first one was falling 1 degree every day. Sorry, was starting at negative 1 and it was rising 3 degrees every day. So we're going up 3 every day, starting at negative 1. The second one started at 6 and fell 1 degree every 2 days. So if you wanted to write equations, those are the ones I graphed. They cross at 2, 5. And if you need to explain the context in this, you would say after 2 days, the temperature in both states is 5 degrees. Okay, and that's all you're doing for your application problems. There are 2 pages for practice. Your answers are on the bottom, so you can check those as you go. And once you're feeling confident, there is a 6.1 Canvas quiz on there, and there is a blank page of graphs. Be really careful. Let us know when you finish the quiz so we can look it over, and make sure you show your work on your paper in case we have any questions. You do have to get 4 out of 5 on this quiz to be able to open up the next lesson. So make sure you are very careful, and if you're not sure why you're getting things wrong, email me or Mrs. Straight and we will check them for you. Have a great day. We miss seeing you guys. Be safe.